Chapter 8 Application of Integrals. Area under simple curves. We consider the easy and intuitive way of finding the area bounded by the curve y is equal to f of x-axis and the ordinates x is equal to a and x is equal to b. From figure, we can think of area under the curve as composed of large number of very thin vertical strips. Consider an arbitrary strip of height y and width dx. Then dA, which is area of the elementary strip, is equal to y dx, where y is equal to f of x. This area is called the elementary area, which is located at an arbitrary position within the region which is specified by some value of x between a and b. We can think of the total area A of the region between x-axis. Ordinates x is equal to a, x is equal to b, and the curve y is equal to f of x as the result of adding up the elementary areas of thin strips across the region PQRSP. Symbolically, we express a is equal to integration a to b dA is equal to integration a to b y dx is equal to integration a to b f of x dx. The area A of the region bounded by the curve x is equal to g of y-axis and the lines y is equal to c, y equal to d is given by a is equal to integration c to d x dy is equal to integration c to d g of y dy. Example 1. Find the area enclosed by the circle x square plus y square is equal to a square. Solution. From figure, the whole area enclosed by the given circle is equal to 4 into area of the region AOBA bounded by the curve x-axis and ordinates x is equal to 0 and x is equal to a. As the circle is symmetrical about both x-axis and y-axis is equal to 4 into integration 0 to a y dx, taking vertical strip is equal to 4 into integration 0 to a square root of a square minus x square dx. Since x square plus y square is equal to a square gives y is equal to plus or minus square root of a square minus x square. As the region AOBA lies in the first quadrant, y is taken as positive. Integrating, we get the whole area enclosed by the given circle is equal to 4 into x upon 2 into square root of a square minus x square plus a square upon 2 sine inverse x upon a. 0 to a is equal to 4 into a upon 2 into 0 plus a square upon 2 sine inverse 1 minus 0 is equal to 4 into a square upon 2 into pi by 2 is equal to pi a square. Example 2. Find the area enclosed by the ellipse x square upon a square plus y square upon b square is equal to 1. Solution. From the figure, the area of the region ABA', bounded by the ellipse is equal to 4 into area of the region AOBA, the first quadrant bounded by the curve x-axis and the ordinates x is equal to 0, x is equal to a. As the ellipse is symmetrical about both x-axis and y-axis is equal to 4 into integration 0 to a y dx, taking vertical strips. Now, x square upon a square plus y square upon b square is equal to 1 gives y is equal to plus or minus b upon a into square root of a square minus x square. But as the region AOBA lies in the first quadrant, y is taken as positive. So, the required area is equal to 4 into integration 0 to a b upon a into square root of a square minus x square dx is equal to 4b upon a into x upon 2 into square root of a square minus x square plus a square upon 2 sine inverse x upon a 0 to a. is equal to 4b upon a into a upon 2 into 0 plus a square upon 2 sine inverse 1 minus 0 is equal to 4b upon a into a square upon 2 into pi by 2 is equal to pi ab. The area of the region bounded by a curve and a line. In this subsection, we will find the area of the region bounded by a line and a circle, a line and a parabola, a line and an ellipse. Equations of above mentioned curves will be in their standard forms only as the cases in other forms go beyond the scope of this textbook. Example 1. Find the area of the region bounded by the curve y square is equal to x and the lines x is equal to 1 and x is equal to 4 and the x-axis in the first quadrant. Solution. Y square is equal to x is a parabola symmetrical about x-axis. Its vertex is O, 0, 0 and its axis is x-axis. X is equal to 1 and x is equal to 4 are two vertical parallel lines. We have to find the area of the region bounded by the curve y square is equal to x and lines x is equal to 1 and x is equal to 4 and x-axis in the first quadrant. Requested area is equal to A is equal to modulus of I. I is equal to integration 1 to 4 y dx is equal to integration 1 to 4 square root of x dx because of y square is equal to x is equal to 2 upon 3 into x raised to 3 upon 2 1 to 4 is equal to 2 upon 3 into 8 minus 1 is equal to 14 upon 3. Therefore, requested area is equal to A is equal to modulus of I is equal to 14 upon 3 square units. Example 2. Find the area of the region bounded by the ellipse x square upon 16 plus y square upon 9 is equal to 1. Solution. Ellipse x square upon 16 plus y square upon 9 is equal to 1 is given. A square is equal to 16, b square is equal to 9 implies a is greater than 0. Center of the ellipse is O, 0, 0. A is equal to 4 and b is equal to 3. So the length of major axis is 2a is equal to 8 and the length of minor axis is 2b is equal to 6. Ellipse is symmetrical about both the axes. Therefore, the area of the ellipse is 4 times the area of the ellipse is first quadrant. Now, x square upon 16 plus y square upon 9 is equal to 1. Therefore, y square upon 9 is equal to 1 minus x square upon 16. Therefore, y square is equal to 9 upon 16 into 16 minus x square. Therefore, y is equal to plus or minus 3 upon 4 into square root of 16 minus x square. Equation 1. Therefore, we find the area of the ellipse in first quadrant. The area of the region OACO in first quadrant is A. Then A is equal to modulus of I, where I is equal to integration 0 to 4 y dx is equal to integration 0 to 4 3 upon 4 into square root of 16 minus x square dx. In the first quadrant, y is positive is equal to 3 upon 4 into integration 0 to 4 square root of 4 square minus x square dx is equal to 3 upon 4 into x upon 2 into square root of 16 minus x square plus 16 upon 2 sine inverse x upon 4 0 to 4. Because of integration square root of a square minus x square dx is equal to x upon 2 into square root of a square minus x square plus a square upon 2 sine inverse x upon a plus c using formula is equal to 3 upon 4 into 0 plus 16 upon 2 sine inverse 1 minus 0 plus 16 upon 2 sine inverse 0 is equal to 3 upon 4 into 8 into pi by 2 is equal to 3 pi. Therefore, A is equal to modulus of I is equal to 3 pi. Therefore, the area of the region bounded by the ellipse x square upon 16 plus y square upon 9 is equal to 1 is area is equal to 4A is equal to 4 into 3 pi is equal to 12 pi square units. Area between two curves. Intuitively, true in the sense of Leibniz, integration is the act of calculating the area by cutting the region into a large number of small strips of elementary area and then adding up these elementary areas. Suppose we are given two curves represented by y is equal to f of x, y is equal to g of x, where f of x is greater than or equal to g of x in closed interval a to b, as shown in figure. Here, the points of intersection of these two curves are given by x is equal to a and x is equal to b, obtained by taking common values of y from the given equation of two curves. For setting up a formula for the integral, it is convenient to take elementary area in the form of vertical strips. As indicated in the figure, elementary strip has height f of x minus g of x and width dx, so that the elementary area dA is equal to f of x minus g of x into dx, and the total area can be taken as A is equal to integration a to b f of x minus g of x into dx. If f of x is greater than or equal to g of x in closed interval a to c, and f of x is less than or equal to g of x in closed interval c to b, where a is less than c is less than b, as shown in the figure, then the area of the regions bounded by curves can be written as total area is equal to area of the region ACBDA plus area of the region BPRQB is equal to integration a to c f of x minus g of x dx plus integration c to b g of x minus f of x into dx. Example 1. Find the area of the circle 4x square plus 4y square is equal to 9, which is interior to the parabola x square is equal to 4y. Solution. The equation of the circle 4x square plus 4y square is equal to 9. Therefore, x square plus y square is equal to 9 upon 4. Therefore, the circle has center O 0, 0 and radius 3 upon 2. The parabola x square is equal to 4y is symmetrical about y-axis. Solving equation x square is equal to 4y and 4x square plus 4y square is equal to 9. Therefore, 4 into 4y plus 16y minus 9 is equal to 0. Therefore, 4y square plus 16y minus 9 is equal to 0. Therefore, 2y plus 9 into 2y minus 1 is equal to 0. Therefore, y is equal to minus 9 upon 2, y is equal to 1 upon 2, x square is equal to 4y, y is equal to minus 9 upon 2, then x square is equal to 4 into minus 9 upon 2 is equal to minus 18 less than 0, which is not possible. If y is equal to 1 upon 2, then x square is equal to 4 into 1 upon 2 is equal to 2. Therefore, x is equal to plus or minus root 2. Therefore, the points of intersection of given circle and parabola are a root 2 1 upon 2 and b minus root 2 1 upon 2. Therefore, the required area is equal to area of the region OAPBO is equal to area of the region OABO plus area of the region APBA is equal to 2 into area of the region OAQO plus area of the region APQA is equal to 2 into integration 0 to 1 upon 2, 2 into root y dy plus integration 1 upon 2 to 3 upon 2 square root of 9 upon 4 minus y square dy is equal to 2 into 2 upon 3 into y raised to 3 upon 2 0 to 1 upon 2 plus y upon 2 into square root of a upon 4 minus y square plus 9 upon 8 sine inverse 2y upon 3 1 upon 2 to 3 upon 2 is equal to 2 into 4 upon 3 into 1 upon 2 root 2 plus 0 plus 9 upon 8 sine inverse 1 minus root 2 upon 4 minus 9 upon 8 sine inverse 1 upon 3 is equal to 2 root 2 upon 3 plus 9 upon 4 into pi by 2 minus root 2 upon 2 minus 9 upon 4 sine inverse 1 upon 3 is equal to root 2 upon 6 plus 9 pi upon 8 minus 9 upon 4 sine inverse 9 upon 4 sine inverse 1 upon 3 square units. Example 2. In figure, AOBA is the part of the ellipse 9x square plus y square is equal to 36 in the first quadrant such that OA is equal to 2 and OB is equal to 6. Find the area of between the arc AB and chord AB. Solution. Given equation of the ellipse 9x square plus y square is equal to 36 can be expressed as x square upon 4 plus y square upon 36 is equal to 1 or x square upon 2 square plus y square upon 6 square is equal to 1 and hence its shape is as given in figure. According the equation of the chord AB is y minus 0 is equal to 6 minus 0 upon 0 minus 2 into x minus 2 or y is equal to minus 3 into x minus 2 or y is equal to minus 3x plus 6. Area of the shaded region as shown in the figure is equal to 3 into integration 0 to 2 square root of 4 minus x square dx minus integration 0 to 2 6 minus 3x into dx is equal to 3 into x upon 2 into square root of 4 minus x square plus 4 upon 2 sine inverse x upon 2 0 to 2 minus 6x minus 3x square upon 2 0 to 2 is equal to 3 into 2 upon 2 into 0 plus 2 sine inverse 1 minus 12 upon 2 is equal to 3 into 2 into pi by 2 minus 6 is equal to 3 pi minus 6.